In this video, I will be discussing about CODAS. It is one of the most popularly used multi-attribute decision making method. CODAS, combinative distance based assessment. So let me give some insights to this method. So this method was developed by Zavadskas in the year 2016. It was mainly depending upon Euclidean distance as a primary source and taxicab distance as a secondary source. In most of the MCDM problems, we might be saying about the Euclidean distance, but here an extra thing called as taxicab distance has been added here. See here, the alternatives which are having the greater distances from the negative ideal solution is one of the most desirable one, whereas in the previous attempt to the other MCDM techniques, we cannot find such a point here. So the two alternatives which we are going to not have a incomparable based upon the Euclidean distance, then and second alternative in the form of taxicab distance is also going to be used. So that is the advantage over the Euclidean distance. So what are the procedural steps are there in the CODAS method? If you find the first step, the basic step is development of initial decision matrix, that is the payoff matrix. So where we can able to see n number of alternatives and m number of criteria. Here I am trying to follow n by m methodology. So the same thing will be replicated. So normalization of the decision matrix. So next second step is we are going to normalize our decision making matrix by using these two formulas, very simple formulas, where NB represents the beneficial attribute and NC represents the non-beneficial, that is cost criteria. And third step is we are going to normalize the based upon the normalizing data in the second step, the weights are going to be multiplied here. In the fourth step, I am going to determine the negative ideal solution by using this particular formula. And in the fifth step, I am going to use two formulas, that is one for Euclidean distance, the other for taxicab distances, and from the negative ideal solution which I have got. And the sixth step is one of the most important step called as relative assessment matrix, and the seventh step is I have to calculate the assessment score, and based upon the assessment scores I have to rank the system. So this is the way how the CODAS system is going to be working out. So let me go into the Excel file. So I will try to solve this entire thing in an Excel file, and the Excel file solved thing will be provided in the description below, so you can go through that Excel file. As a part of demonstration of CODAS method, I am selecting a published problem, like in a very good journal papers it has been published. So here the problem is selection of a best material for a cryogenic tank storage for transportation of a liquid nitrogen, and this is the reference which I have used here. And here it consisting of basically three beneficial attributes, that is toughness index, yield strength and Young's modulus, and four non-beneficial attributes, density, thermal expansion, thermal conductivity and specific heat. So these are the materials which they have given, that is alternatives for our MCDM problem, and this is the payoff matrix which we have to get it. So the up to here the step 1 will be completed. So I can highlight here also, it is as a step 1. Okay. So next what we have to do? We have to calculate the weights. So basically the weights has been taken from the same published journal paper. So I am not going for estimation of the weights. I am taking the same weights for this particular attributes as it is. So next thing is I have to calculate the max min values. So why this max min values means, in the second step we are having the maximum values and minimum values. Suppose here I have to go for normalization. So for beneficial attributes I have to take the maximum values, for non-beneficial attributes I have to take the minimum values. So for calculating of maximum and minimum values, I am trying to choose this particular option called as max min values. So simply we will get max of this entire column, I will get the max, simply drag it to the up to beneficial cases. Similarly try to get the minimum values, that is non-beneficial, minimum values are the better here, so I am just dragging it up to here. So these four comes under the category of beneficial, and these 3 comes under the category of beneficial, and these 4 comes under the category of non-beneficial, like this. Next, so next what we have to do, we have some sequence of steps as I have discussed earlier in the PowerPoint. So these steps I have to follow it. So I will slowly follow these steps. Okay. So here I have step 2 as normalized decision matrix. So for normalized decision matrix, what I have to do, I have to take is equal to symbol xij, that is this one, divided by maximum, this value, go for dollar. So dollar is going to log this particular cell because this 770 is common for this entire column computation, no, that's why. So similarly do it for the second column, that is yield strength also, xij divided by maximum value, go for dollar symbol, enter. Similarly do it for the third column, that is Young's modulus xij divided by 217, go for dollar symbol, enter. Okay, so the dollar symbol indicates that it is going to log row and column. Next, minimum. So in the minimum, what I have to select, first I have to select the minimum value, that is 2.68, press F4 divided by the current value. Similarly, fifth column, this value divided by 21.4, next is equal to this one, F4 is to log that particular cell, next is equal to 0.06, press F4 divided by 0.016. So these are the values which we have got it. What I am doing is selecting all, just to drag it up to bottom, so that we will get some kind of values like this. So this completes our normalized matrix. So next one is we have to go for weighted normalized matrix. So weighted normalized matrix is a multiplication of the weights to the normalized matrix. So what are the weights? Here the weights are is equal to this one, go for F4, that is locking that cell, next this value, enter. So similarly do it for the second row, F4 multiplied by this value, next, okay. Now just drag it, select it to the last and just drag it up to the bottom, so that you will get the all values. Okay, you can cross verify one or two values whether those are in correct fashion or not. You can cross verify at any time, okay, whether they are in correct manner or not. Just for our understanding, I am cross verifying it. Okay, everything is fine. Next step is we are going to determine the negative ideal solution points based on the weighted normalized decision matrix. So for that one, the formula is very simple. We have to take the minimum value. So just I will type is equal to minimum of this entire column and just press enter. Just drag it up to the last 7 attributes, so that we will get the minimum of all these values. After then I have to calculate the Euclidean distance. So Euclidean distance, there is a formula here. You can able to observe here, Rij minus Nsj whole square. Nsj means this value, Rij is weighted normalized value. Okay, we have to take summation and root also. So what I will do is, first of all Rij minus Nij square, slow I will try to enter the value slowly like this, is equal to Rij minus Nsj whole square, close the brackets, plus, because I have to do the summation also, no, in the formula, if you see the formula. And again here this K26 is common, no, for all that entire column wise. So just I am pressing F4 button, okay, since it was common. Variable one is this 7 alternatives, it is varying. Next this minus this, press F4, close the brackets, whole square, next plus, so I have closed the brackets. Then for this formula what I am doing is I have to apply the square root also, no. So there is a formula for square root, SQRT is the formula for the square root. Just I am inserting the square root and just I am pressing the enter button, so that I have got the value. So similarly what I will do is I will just drag it up to 7 alternatives. For cross check you can able to verify once again. Okay, so this is the Euclidean distance. Next I have to go for the taxicab distance. So taxicab distance, the formula is just absolute value of the Ri minus Nj, and we have to sum it. So for that one what I will do is, there is a formula here called as ABS of the current number minus the negative ideal solution. Since the negative ideal solution is common for the entire column, I am trying to give F4 there. Next this one minus this one, press F4, close the brackets, plus ABS of this minus this, press F4, close the brackets, plus ABS of this minus this, press F4, close ABS of this minus this, press F4, close the brackets, ABS of this minus this, press F4, close the brackets, plus ABS of this minus this, press F4, close the brackets, and I have to take the summation here actually. So in meanwhile I have introduced a summation plus symbol, so that will be the final case. Just I press enter button, so that I will get 0.19116 and drag it up to 7 columns. Okay, row wise you can drag it, you will get TA. That is the case where up to Euclidean distance values we have constructed. Now based upon the Euclidean distance, I have to construct the relative assessment matrix. Here in this relative assessment matrix, this is the formula EI minus EK plus 0. This is coefficient of determination. I will consider here the value as 0.02, because this is the standard which we have to take in the range from 0.01 to 0.05. So I will take the same formula here. There is no change in the coefficient of determination value. I will take it as 0.02 and I will execute this formula here. So what I will do is I will try to paste this one here for easy convenience. Just I am pasting it here. Okay, so EI, see here very carefully we have to think. This is the first one, EI, because every time we will get the same Euclidean distance. EK means in that particular thing it will be constant. So here EI has to be changed for every column, no? So that's what I will do is press F4 button, so that the current cell will be current column has to get locked, because row it has to be vary. Minus EK is this one, so just I will press F4 because there will be no change here. Next 0.02 multiplied by again this value, I will just copy it because the same thing, no, just copy it, multiplied by, next multiplied by what I have to do, I have to go for TI, just press F4 two times, so that that current column will be locked, row will be varied. So I will repeat this step for the remaining matrices, so don't get confused here. This is the major step which we have to follow. So we will get 0. Now if you drag it to the entire column, sorry, last thing I have to ignore. If you drag it to the entire column, we will get the variables of all these varying values. So this is the important step which we have to take very carefully while formulating. I will do it for the second thing also. See, brackets EI for the second step, EI, no, we are going with the second column, no. So in the second column, the first thing is this one, minus, I have to go with the second one because this is constant for the entire K. So press F4, but for K33 what I have to do, I have to press 3 times F4, so that K will that current column will be get locked. Next close the brackets, plus 0.02 multiplied by, and this formula will be common, no, I am copying it, pasting it, multiplied by, sorry, one time. Now TI, so TI we have to select the first one and it has to be vary for the all columns. So press F4 key 3 times minus T2, this will be constant, that is we are going for the second alternative. So press F4, close the bracket, enter. Okay, you will get the value as 0.068. Just drag it up to the bottom. Okay, like that you have to do it for the remaining 7 alternatives. So for the last column, I am going to do it again once again, please check it. So the current cell, press 3 times F4 so that the current column will be get locked and row will be varied minus that current value. This will be common for the entire term plus 0.02 multiplied by I am copying this one once again because this is a common thing, closing the bracket, next multiplied by Ti, press 3 times F4 minus this cell, press F4, close the brackets, enter. Okay, 0.0786, just drag it up to the bottom cell. So this completes our construction of the relative assessment matrix. Note here that in the diagonal we have to get 0, that is the indication that where we are going in a correct manner. Okay, and the last step is now this step has been completed for us. Next last step is we have to go for calculation of the assessment scores. So for calculation of assessment scores, what we have to do, we have to go for calculating of means we have to take the summation of all these things. So summation of all these values, we will get the assessment scores like this, drag it, that's all. And the rank, so rank is a simple one, rank rank of this current number comma this entire range, press F4 to lock that particular range, then press enter. So after dragging to the downward section, I am just changing it the color and just dragging it up to the down section. So here by seeing this one, I have got third alternative as a best alternative. What is the third alternative? I can able to get it from here. See that the third alternative is stainless steel of 301, stainless steel of 301 FH. So this is the best alternative which it has been chosen from the CODAS method. The best alternative is third alternative. If not, I can go with the second ranking. I can choose titanium 6, aluminum 4 vanadium material also as a second alternative, best alternative. So this is the way the CODAS is going to be working out.